Today we will discuss one of the important component which used in the electronic gadget, that is the piezoelectric transducer. This piezoelectric transducer are actuator as well as a sensor which are used in the electronic gadget. You see on the screen that there is a device which is pressure is giving to the device to the metal, and then we are generating a electricity. So before starting the transducer, first we discuss what is the piezoelectric effect. So what is the piezoelectric effect? Piezoelectric effect can be defined as the ability of particular material for generating an electric charge in reply towards the applied mechanical pressure. When we apply the mechanical pressure on the crystal, on the material, then there is a generation of the electric charge. That is the piezoelectric effect. One of the exclusive characteristics of this effect is that it is reversible. So that means the material displaying the state piezoelectric effect, it also displays the reverse piezoelectric effect. Means it work in the straight as well as in the reverse mode. Moreover, you see on the screen that here we are having a material and on which the pressure is given, and then you see on the voltage that the electric charge is generated. So the first piezoelectric effect was invented in the year of the 1880 by the two scientist brothers, namely Marie Curie and the Jacques. Then this effect was found from the applied pressure to the crystal, unlike the quartz form an electric charge in the material. When we apply the pressure on the crystal, then it produces the electric charge. Afterwards, they refer to that the scientific fact like the piezoelectric effect. First, just they realize that there is an electric charge generated when the pressure is given to the crystal. After that, the name was given, it is the piezoelectric effect. So the Curie brothers quickly invented the inverse piezoelectric effect after they confirmed that whenever the electric field was required on the crystal terminals, it will lead to the distortion. Means inversely it will also be work. So this is the inverse piezoelectric effect, and the piezoelectric effect name were taken from the Greek word. The meaning of the piezo word is the pressure, otherwise the squeeze, whereas the electric means the amber. So piezoelectric means when we give the pressure to the metal crystal, then the electric charge generated. So you see here on the screen that here the pressure is giving, it is showing the inverse piezoelectric also. Here it is giving in the upward direction, and moreover it is in the downward direction, and both are displaying it. Whether the piezoelectric material is located beneath mechanical stress, a transferring of the positive as well as the negative charge carriers within the material takes place, and that results during an exterior electrical field. When they inverted, an external electric field also extends the piezoelectric material. So the application of the piezoelectric mainly involved in the fabrication as well as the sound detectors, microbalance generation of the high voltage as well as the electronic frequency, very fine optical assemblies focusing that are used for that always use the piezoelectric effect, and we use these type of devices. And this is the foundation of the scientific method by the atomic resolution like STM, SFM, AFM and scanning probe microscope. The common application of the piezoelectric effect is the explosion source of the cigarette lighters. So what are some of the examples of the piezoelectric effects are: electricity can be generated by squeezing a piezoelectric material. The piezoelectric effect in a crystal is defined as during the material compression. So So we require such type of material which creates the piezoelectric effect, in which we use the piezoceramic materials. So piezoceramic material like the piezoelectric crystal is placed among the two metal plates that we have shown. Then the piezoelectricity can be generated whether the material is squeezed by applying the mechanical stress. Here we are having the piezoelectric material, and you see on the screen that there is a metal plate, and in between that there is a piezoelectric material, and that is the lead, zirconate and titanate, and that is defined as by the compressing produces electricity, and that will be recorded through the battery. So there will be an voltage potential across the material we generated, and that produce the electric charge. So metal plates in the above circuit can be sandwiched by the piezoelectric crystal, and the two metal plates gather the charges, and which generates a voltage which is known as the piezoelectricity. Means we are having the two metal plates, in between that there is a piezoelectric crystal, and when the pressure is applied, then it generates the piezoelectricity. So in this method, piezoelectric effect functions as a small battery and it generates electricity. So this is called the direct piezoelectric effect. There are several devices which can use direct piezoelectric effect, where we have a pressure sensors, microphones, hydrophones, sensing type of devices which uses the direct piezoelectric effect. Another is the inverse piezoelectric effect. The inverse, or sometimes it is called the reverse piezoelectric effect, can be defined as whenever the piezoelectric effect is reversed. So, and this can be formed by applying the electrical energy to make a crystal expand. In the previous it is squeezing, now in this case for the reverse piezoelectric effect, the electric energy given to expand the crystal. The main function of this crystal is to convert the electrical energy into the mechanical energy. So by employing this effect, we can develop device to generate the audio sound waves, and the best examples are the speaker or the buzzers. What are the main benefit of using these speakers is that they are extremely thin, which creates them functional in the variety of forms. So even sonar transducers as well as the medical ultrasounds utilize the inverse piezoelectric principles, and non-audio reverse piezoelectric device comprise actuators as well as the motors. Now you see, this is the, on the screen you are seeing that this is the inverse or the reverse piezoelectric device, and you see that electrical signal we are getting, the sound system now it is expanding, now not squeezing but it is expanding, it is moving outwards. So again metal and PZZ material, piezoelectric material, we will put in between the two metal plates. Now the sound waves are created. This is another example of the piezoelectric effect. One is direct piezoelectric effect, second is the inverse piezoelectric effect. So piezoelectric effect results from the linear electromechanical interaction between the mechanical and electrical state in crystalline material with no inversion symmetry. The symmetry of the material will be the same, but it produces the, when the mechanical pressure is giving electrical charge generated in the crystalline form. So the piezoelectric effect is reversible process, and material exhibiting the piezoelectric effect also exhibit the reverse piezoelectric effect, the internal generation of the mechanical strain resulting from an applied electric field. So, if we take the example of that, we take the lead, zirconate, titanate, crystals will generate measurable piezoelectricity when their static structure is deformed by about 0.1% of the original dimensions, and conversely those same crystal will charge about 0.1% of their static dimensions when an external electric field is applied. So, the inverse piezoelectric effect is used in the production of the ultrasound waves. Now, what material we use for the piezoelectric effect? So, we discuss some brief about the piezoelectric material which have been around since the 80s and paved the way for many game changing inventions. Serving from the sonar in the World War, these materials have now caught eyes in the inverters for their mystic characteristics. Moreover, wireless sensor network, Internet of Things rules nowadays in 21st century. So, keep these novelties up to the running power requirement have become the greatest challenge. Hunt for a sustainable, reliable, renewable energy sources caused researchers to stumble upon the power harvesters and the piezoelectric materials. So, let us see some of the voltage to explore these new age power harvesters. Now, we will choose that material so that we can get the good result through this. So, in our everyday lives, we go over different circumstances where we need to quantify physical quantities like mechanical pressure applied on the metal, temperature level, tension level, and so on. For the multitude of the utilization, we really wants a device that could gauge these observes units and alignments natural to us. So, one such device which is generally helpful to us is the transducers. So, transducers basically is an electrical gadget that can change over an actual amount as a corresponding electrical amount, either as voltage or the electrical current. So, from the huge pool of the different type of transducers, they are used for the conversion of the electrical charge into the energy with help of some solid material. So, now we discuss what is the piezoelectric transducer. Basically, piezoelectric transducers is an electrical transducers which can change over any type of physical quantity into a electrical signal which can be utilized for the measurement. It means when we apply the mechanical energy, then it will convert into the electrical energy. So, piezoelectric transducers is an electrical transducers which can change over any type of physical quantity into a electrical signal. So, an electrical transducers which involves properties of piezoelectric material for transformation of actual amount into the electrical signal is known as the piezoelectric transducers, and it uses piezoelectric effect for the measurement of the charges in any quantity by conversion of energy to the electrical charges. So, piezoelectric material, you see that this is a one type of the piezoelectric transducers. So, piezoelectric material which shows the properties of the piezoelectricity as per which on the application of the mechanical pressure or the strain prompts the generation of the electric voltage related to the applied pressure. That is the piezoelectric material. Means when the mechanical pressure or the strain prompt the generation of the electric voltage relative to the applied pressure on the material, that material is known as the piezoelectric material. This produces electric voltage can be measured using the voltage measuring instrument to compute the value of the stress strain applied to the material. Means how much stress we are giving and how much electricity is generating through these transducers. So, a transducer is a device or the instrument that changes one type of energy into the another. With the regards of the electrical designing and the physical sciences, a transducer is much of the time used for the change over an actual amount, like the power, strain, temperature of the light into the electrical sign. Now here we are just converting the pressure into the electrical energy. The objective of this transducer just to control the physical quantity. Physically, basically it is used to convert the energy from one form to the another. So, so now in the piezoelectric effect, we just choose the material, so that mechanical pressure or the twisting given to the material, and then electric field generated, and that this bidirectional connection between the mechanical pressure and the electrical charge is normal for the piezoelectric material. So, piezoelectric material are many times translucent in the nature and display a non-centrosymmetric gem structure. So, most widely recognized normal piezoelectric material is the quartz. Yet there are additionally different engineered materials with the piezoelectric properties, but quartz are generally used as a piezoelectric material. Another materials are lead, zirconate, titanate, and other many, and that is the polyvinyl diene fluoride, that is PVDF, also used as a piezoelectric material. So, the piezoelectric material can be used to produce the either the direct piezoelectric effect or the inverse piezoelectric effect. Sometimes the piezoelectric effect can be grabbed into the two principal modes. One is the direct piezoelectric impact, and second is the opposite piezoelectric impact. So, in the direct piezoelectric impact, when the mechanical pressure is applied to the piezoelectric material, it causes a removal of the charge inside a material and prompting the edge of an electric voltage across the material, and this impact is taken advantages in the different applications like piezoelectric sensor and actuators. Means in piezoelectric actuators and sensors we use direct piezoelectric effect. In the opposite piezoelectric impact, for this situation, when an electric field is applied across the piezoelectric material, it goes through an adjustment of the shape or the mechanical deformation, and this is normally used in the piezoelectric transducers and the actuators. How to measure the piezoelectric transducers efficiency? So, measuring, we are giving the pressure and how much electricity are generated, means how we can measure the physical parameter of the transducers. So, measuring the productivity of the piezoelectric transducers includes the evaluating its capacity to change over the mechanical energy into the electrical energy or the other way around. So, the proficiency is normally communicated as the proportion of the valuable result energy to the information energy. So, the estimation cycle can shift contingent upon like whether you are zeroing in on the piezoelectric transducers as a sensor or as an actuator. So, there are some common points for estimating the proficiency. First is the calibration. If we talk about the piezoelectric sensors, then the calibration is important. So, prior to the proficiency estimation, adjust the piezoelectric sensors to exact and steady reading. So applying known the mechanical improvement or record the relating electrical reactions in the form of the calibration. Another point for the sensors also, input mechanical energy, applying the controlled mechanical boost to the piezoelectric sensor. This could be as power, tension or the speed increases the contingent upon the sensor type and the application. Another measure the electrical output. Now record the electrical result produced by the sensor because of the mechanical upgrade, and this could be in the form of voltage or in the form of the charge. So it is very important. Now the calculate the efficiency. How we calculate the efficiency means ascertain the efficiency by contrasting the electrical output with the information mechanical energy. So productivity defined by the etah and can be expressed as efficiency percentage is equal to useful output energy divided by the input energy into the 100. Similarly, that is the efficiency measurement. Efficiency is equal to input energy divided by useful output energy into the 100. So in both the form, means direct or inverse, we can find out the efficiency. Now what are the losses in that? We can consider the losses. Consider any losses in the system like electrical losses, hysteresis losses or the mechanical losses. These losses can affect the overall efficiency of the system. Now up to now we have discussed the many type of the piezo, what are the characteristics and what are the essential points in the transducers that we have discussed. Now we will discuss the type of piezoelectric material which we will use in the piezoelectric effect. Generally we use the quartz, but normally available are the quartz, but the rock salt, topaz and tourmaline and another that are the other materials which are also used in the photoelectric materials are the lead zirconate, the PZT, PVF, barium titanate and lead titanate and other from lithium and other lead piezoelectric ceramics are also used in the piezoelectric material, which has a very large number of the properties. Quartz is an exceptionally steady precious stone which is normally accessible, yet it has a little result levels. So it is used, it is a most noteworthy result estimation through this quartz, and it is naturally occurring, and then that we can use in the many devices. All piezo materials cannot be utilized in the piezoelectric transducers. Some condition needs to be satisfied. Material should have the high output value, accessible in the different type of shapes, adapt the shape without adapting their properties. Without changing their properties, the shape must be modified whenever we require. So these are the piezoelectric materials which use in production of the transducers or in the sensors or in the actuators. Next we will discuss the working of the piezoelectric transducers. Thank you very much.